Maybe Shiba Coin is to Dogecoin as this stuff is to Bitcoin, because Dogecoin is a Bitcoin clone completely, right? But if Shiba Coin is not proof of work, that'd be great.
Shiba Coin, Shiba
I hate
token.
I hate all of
What
this, man.
exactly is this? Yeah, this is
Da, da.
ShibaToken.com.
There you go. This oh
Read our.
stop.
Oh, hey Dom, I played a little bit of Returnal.
Yeah, what'd you think?
I played it for about an hour.
Okay.
Uh, and I thought it was very well put together, and I did not enjoy myself, which is
I kind of predicted that.
you did. Okay.
I had a guess that you would like think it is technically very cool and also like maybe not that interesting.
Yeah, I wish I liked it more. I think I have an issue with games that are just bleak, and that
It's
game is
bleak as
bleak.
fuck.
It's
Yeah.
bleak as fuck.
Yeah. Here, let me
I
test
think
the
I
audio
need
on
like the
Returnal
happy
real quick.
overworld that you can go into that like is a reprieve, you know.
Yeah, there's no. Well, the problem is so many good what's the word, roguelikes have a like the overworld grows and gets better, and this one you wake up at the same shitty place with the same nothing every time. Like you don't have any characters pop up there. It's it's sad.
I was also hoping to have some kind of like hook that would make me keep wanting to play, but like I died a couple times because I got into a room with a gigantic tentacle thing.
Hmm.
And
That'll
there was
happen.
like two different kinds of them, and they both jacked me up pretty bad.
Hmm.
Um,
To which I can only say get good, but
yeah, I
it
know.
well it's weird because like
It's very Bloodborne actually in the way that they kind of design those bosses or mini
yeah,
bosses as it were.
yeah, and the it's interesting how simple those feel compared to the things I found later. But I've like had that experience a
Okay.
couple times where I find like where like I get to the giant tentacle thing and I'm like, wow, like I am not going to get past that part of this game. And then like on the second try or third try afterwards, I'm like, oh well, okay, I guess I figured out the tentacle boss. And
Okay.
then you're on to like the next bullshit. Like it's very surmountable, and like I can go through worlds 1 and 2
Yeah, I think I
really
found one
really
of these
fast.
guys.
Let
These
put,
horrible things.
let's see. Oh yeah, that doesn't look good.
No, it looks kind of yeah. And oh no, I feel like I was able to kill this guy. There was like a really big gorilla looking guy with tentacles in the
Mhm.
first level.
There's like a gorilla tentacle monster and a dog tentacle monster, and sometimes you get a big dog. Uh,
I think I might have gotten killed by the big dog and definitely the big gorilla one that was like the size of the room.
yeah,
And
fuck
I
that thing.
found that I couldn't even dodge him. It was his physical attacks that jacked me up.
Interesting. That sucker's
Um,
dope, man. Oh, so
yeah.
weird.
Um, so the guns are cool. I didn't
Ha-
like that there were enemies I couldn't kill because they had like a red silhouette around them. And I guess you
Wait.
have to like figure out how to kill things with a red silhouette.
Oh yeah. I feel like you haven't finished the tutorial yet. Somehow.
Maybe I was playing for an hour and like I figured like there was also a door that was covered in red and it said like you must get this technology to get
Mm.
past this.
You
And I
you
like
get
ran
it.
around. Yeah,
You get it
sorry.
pretty. You get it pretty quick. It's like definitely the
Okay.
next thing you're gonna get.
Well, then I died because I ran into one of the big things.
That's fair. Yeah, it sucks. There's enemies
Yeah.
with red shields before you can kill red shields. That didn't happen to me. That would have been really frustrating. That seems like bullshit.
It was well, actually, there was a lot of red shield stuff before I could kill things with red shields. What do you do to kill things with red shields?
Melee.
Oh,
But like,
yeah,
I don't
I
think you have
didn't get
melee yet.
melee.
Yeah.
Yeah, I didn't get melee.
No, there's a whole there like you have to find the sword to do the melee with. So you're not crazy. Uh,
Oh, and then do you have the sword when you restart the game?
you do.
Oh, maybe
Yeah.
I just rolled the wrong. I
Maybe you
just
got
rolled the wrong dice.
bad set of rooms.
Yeah,
Did you get the secondary fire?
yeah. I
Okay.
had two different guns. I had got the shotgun and I got the assault rifle.
But did you get the second their like superpower?
I mean, you get them as soon as you get those guns, right? You're talking
Oh
about
yeah, yeah,
pulling down
yeah,
the left trigger. Yeah.
yeah, yeah. It's like it's interesting because each one has a like the alt fire and the gun are like not actually connected. Like the shotgun alt fire rolls random as well.
Mega rocket. I want the mega rocket.
Uh, yeah. Well, how dope is the control usage though? At the very least, they nailed that. I think.
Ish. I don't know. Like
Ish.
I like when I had the assault rifle,
Hmm.
I felt like first of all, is it even worth aiming in that game? Like, do you even need to pull the left trigger down to aim?
I turned aim assist up to max.
Okay, yes, I did too. I felt
Yeah,
like I was like, should I turn it back down? But I just kept it there because I had a hard
I
time aiming.
it's maybe the only difficulty slider in the game, and I was like, I'm gonna make this more fun for me.
Yeah. Okay. Well, I think I'm encouraged by the fact that I just missed an important thing and I can go back and try it again.
Yeah,
Yeah.
yeah. You at least want the melee, but I don't know. It's hard and punishing and bleak. You're right on all counts.
Yeah. But I'm guessing at some point you start to feel like a badass. Is that true?
I feel like a badass pretty regularly in that game. Yeah.
Okay. Yeah, I think that's the thing I'm waiting for because right now I'm kind of just like a
Mhm.
how would you say it? A chump. Um, and I'm just waiting for what makes me feel good rather than kind of slightly scared and weak
Yep.
all the time.
Yeah,
Uh,
that makes sense.
yeah. Now I also played a bunch of Nex Machina, or at least I played like 2 hours of it.
And was that more fun?
It is more fun. It's really satisfying, but there's literally only like 90 minutes of gameplay, if
Bummer.
even that. Like you can beat it in an hour.
Huh. Okay.
Um, because the mode that you get into is called arcade mode. There's no saving or anything like that. So
Mhm.
like you can't make somebody play a game that doesn't have any saves or continues or well, it has continues, but no like password style. It's like playing an old school NES game, right? With no
Oh,
saves.
that's a little rough.
And there are 6 worlds that you go through, and after that, you're just done. I think I played it on the rookie difficulty level. I don't know if you go up in the difficulty level whether there's more going on.
I assume there's not more
Um,
going on. I assume it's like arcade where they're like you just get to get more points or like the mastery of the higher difficulty level. That's
yeah. Have you ever been motivated by points in a game?
no,
Yeah.
no. Trophies can do it for me sometimes. They can sometimes I let them point me towards like fun. Uh,
Yeah, so they have like a ton of different achievements built into the game where it's just like, beat the game with this weapon or without doing X, Y, or Z. But you know how Hades had heat, right?
oh yeah, so good.
Yeah, but that mechanic was really good because they tied it really intelligently with the rewards that you would get.
Man, Hades just killed it.
Hades did really well, and also with heat, those constraints were put upon you, and you didn't really have a choice, right? You just had to do it. Whereas with Nex Machina, I just realized this company just really loves their puns in their game names. Returnal,
Returnal, Nex Machina. Yep.
yeah. With Nex Machina, you have to kind of like opt yourself into playing a certain way to get the achievements. And if I cared about achievements in the first place,
Yeah.
it
Then
would
you might.
annoy me that like I'd have to be like constantly aware of whether what
Hmm.
I was doing was satisfying that or not.
Yep. Yep. That checks out.
Game looks really good though. I think it was like actually one of the original PS4 Pro titles.
Oh,
Um,
interesting. It was one of the ones. I mean, since they were a PS4 launch game, that kind of makes sense.
so I mean, it kind of looks like StarCraft 2 on steroids, right?
Hmm.
This style.
Oh yeah.
It looks really beautiful. Um, the particle effects, and I guess this is probably true of Returnal as well. This company is just like their bread and butter is just like particle effect demos.
Well, I was gonna say
Tech
it's so
demos.
funny because yeah, everything you described about Nex Machina makes it sound almost exactly like Returnal.
Yeah,
Like 6 worlds, you kind of start with nothing, but they managed to tack like a bit of progress and story and like just make it take a lot longer for their latest.
Yeah, I have to admit, with Returnal, I'm a little bit intimidated by the idea of like starting a 3 or 4 hour run because I just don't play video games that way anymore.
Mhm. Yeah.
Um, or at least the games I can play for like 4 hours are like Yakuza, where I'm just like running around Tokyo, like buying beer from the convenience store. You know, like I'm not like on all the time. Which I have to imagine with Returnal, you kind of have to be in a bit of a Zen state to like really get through it,
I think
right?
so, and it's kind of like it's weird too because like
Oh,
it has
how
that
to farm
property.
ether? Maybe I should be reading this.
Oh,
I
interesting.
want ether.
You want Ether? Yeah, it's
I like farming.
what's the current price of Ethereum? Is it like 5,000 a coin?
How much is ether right now?
I discovered that I had a Coinbase wallet that I forgot about.
Oh,
Uh,
really?
and
Was that from work?
it was from work, yeah. And at some point, one of our fine coworkers convinced me to like. He was just like, you know what? If you're not sure, just like have Coinbase buy
Wow.
you $50 of crypto every month. Like, just like put in a regular buy order, do it. So I think I like ended up buying maybe $1,000 in crypto over, 2014, 2015, 2016.
Okay.
And now I have a $10,000 crypto portfolio that I am trying to get out of. I don't want it at all.
So you are leveraged. You're basically now invested into the world of proof of work
No, I want out, man. I want out
cryptocurrency.
so bad.
Okay.
But I was about to sell it, and then Elon made
This
some
year has been
tweet.
kind of crazy. Look at this.
I know.
Everything that we've seen has been basically with the okay, worlds started falling apart. Well, 2016 ish, end of 2016,
Hmm.
right? November is right here. World started falling apart. Well, the world started falling apart long, but it started getting like obviously bad, right? And then like then the pandemic is right around this ish, and look at where Ethereum is going.
Isn't that fucking weird?
I
Yeah.
think it's negatively correlated with how good the world is doing.
And like it's going down again, so I was thinking I would hold on to it, but also I should just get rid of it.
Yeah.
You know why it's going down again though?
Why?
Because Elon Musk tweeted that Tesla won't let you sell your car in Bitcoin anymore.
Oh
This
yeah, I
fucker,
heard about that.
this fucker's stealing my money even when I don't want to be involved in it.
Oh yeah, and then I did you hear about this Vitalik India COVID?
Oh no.
Yeah. So
Donates
Vitalik
Ethereum
Buterin,
and a Shiba?
benevolent dictator of Ethereum, has donated 500 Ethereums. Okay, that is an Indian website, so maybe they no, that's quartz.com.
I was gonna say QZ is absolutely not.
Oh God,
And 50
Ethereums, guys, come on.
and 50 trillion meme coin Shiba Inu.
Yeah, so basically, there's like a Shiba Inu cryptocurrency that's worth more than every company you and I have worked for, like put together. This is just the world that we live in, right? And so
So
he donated it all.
wait, Shiba Coin is not Doge? It's a different one?
It's a parody of Doge, which itself is already a parody of
Sorry. So
Bitcoin.
the parody of the parody cryptocurrency is worth $6 billion.
No, I actually think it's Vitalik's piece of Shiba was worth 6 billion, right?
Fuck me, man.
Oh no, wait, it is only 1.5 billion. I mean, credit to this guy. He had this stuff that was nominally worth this much money, and he just donated it to the India COVID Crypto Relief Fund, which I don't know if it's ever going to get liquidated.
The COVID
But
crypto.
that one act caused a 35% drop in the Shiba Inu coin's price, which I don't know. Like this is completely non-liquid. This is not going to buy a respirator for the Indian, citizenry.
Fuck, man, that's hilarious. Why? Why
I
is it
don't know.
like this? Oh shit. Okay. Yeah.
Well, you should get off your ether,
I'm gonna
or
get
don't.
off. I'm gonna
And
get off all
maybe
my
you're one of the
crypto.
good guys that has ether.
That's impossible. I don't think you get to be a good guy and an Ethereum owner at the same time.
Yeah,
I can't figure out how to sell it, to be honest.
yeah. Over the weekend. I was trying to read about what Tether was. Right, because Tether is this mysterious currency that
Yeah,
Do
isn't
you
it
do you know what
like?
Tether is?
I mean, I remember our coworkers talking trash on it. I
Yeah,
think
yeah.
because their
Tony was
their
not a fan.
well, it's because their
Uh,
market cap is impossible. Like the amount of money they claim to be working with is just not real. I
yeah.
think that's why he was so down on it.
So they call it a stable coin, right? And the idea behind this is that it is backed by U.S. currency
That's right.
with some reserve percentage, right?
Jeff, I want you to know
Why?
I'm burning down a rainforest right now to sell my crypto.
Oh, so you're selling your crypto like as we speak right now? Is that what you're
Yeah,
saying?
I'm done. This stream was the moment. You shamed me. But yeah,
Wow. Um, well,
go
it was
go.
an impulse crypto purchase and now an impulse crypto sale.
Yeah, and it made me $8,000. So
And you can buy yourself like a high powered graphics card that you can then use to mine more cryptocurrency.
the dream
I
is
almost
alive.
called it just crypto, which is a pet peeve of mine, but I think that ship has sailed, right? If you own cryptocurrency,
Unfortunately,
you own crypto now,
you
right?
own crypto. Yeah.
Yeah. Okay.
Yep. Yep. We're there. But yeah. Right. Tether is supposed to be backed by real dollars, but something
But
like
why do you need Tether? Is it that if you're buying Bitcoin, you're actually buying it using Tether? Is that how that works?
I am not sure. And also like to right. Why would you want the currency that works and it is tied exactly to the dollar? Because isn't that not why we're using crypto? Yeah. I'm confused. I'm confused by the whole thing.
Yeah. And so this is Tether actually isn't 100% a dollar, right? It's kind of gone up and down around it.
Oh
And this
wow.
is basically how much the public believes that the company that's behind it is actually backing it, which they must not be at all. There's probably like $10 in the piggy bank here, right?
So it has a market cap of $60 billion, and it's done $200 billion of transactions in whatever time frame you're looking at, 1 year. That's ridiculous. Who are these people?
Yeah, I don't really know.
How's our Stellar doing now? That's what I want to know.
Oh, okay. XLM.
I saw it in the header there. Oh yeah, let's see. Just keep going to. Oh my God, it's worth
XLM
so
has a
much.
smaller. Oh, you know what? It has 10 times the market cap of Shiba Coin. Oh, I don't know if that makes me feel bad or good. Um,
Hey, it doesn't boil the
yeah,
oceans.
we are the same fucking assholes. Luckily, Stellar isn't
Doesn't boil
isn't
the
a proof of
oceans.
work. It's not a proof of work system. So
Yeah.
we have that going for it.
Yeah, there is no
Um,
rainforest or ocean sea temperature rise that we can attribute to this one.
yeah. So all it is just ridiculous
Yeah,
and
it's
not like actively harming the environment and ridiculous.
which like man, like that's what maybe Shiba Coin is to Dogecoin as this stuff is to Bitcoin because Dogecoin is a Bitcoin clone completely, right? But if Shiba Coin is not proof of work, that'd be great.
Shiba Coin, Shiba
I
token.
I hate all of
What
this, man.
exactly is this? Yeah, this is
Da, da, da.
ShibaToken.com.
There you go. This oh
Read our whiff
stop.
paper.
What?
Uh,
I mean
it's just ERC20. So yeah, it's
oh,
just yeah.
it's just Ethereum.
Yeah. Okay. Well,
It's
good for you guys.
Ethereum for Shiba furries, I guess. I love that this furry Shiba has a FUD tattoo, like a sailor on their arm. There's so much going on here. Oh,
Yeah.
uh, this really hurts, man. Fuck.
Let's talk about the game.
Oh,
This
please
is
take me away from
this is
crypto.
let's go from
I
Shiba Coin to Shiba Tank.
I'm no longer a crypto owner, so I have no more interest in that field.
You still got your XLM floating out there. Your XLM debt, your
Yeah,
XLM denominated bonds, basically.
oh, that
That's
is
what
what
you
they are.
got. Yeah.
Uh, dude, this is coming through crystal clear.
Okay. This is the
I'm
new. This is the new normal.
yeah, I'm watching this on just on the stream coming through to me at 60 FPS, and then on Twitch it looks really good.
Nice.
Yeah,
Check this
okay,
out.
I'll pay for that. Yeah, what are you gonna do?
So the builder is walking around the block, and if I blow up the walls, the builder turns around.
Recalculating.
Yes, reticulating splines. Does that reference mean anything to you at all?
I have played many a Maxis game. Yes.
Okay, got it. This down here does not look normal. That does not look.
So I mean, go back to the next Machina screenshot. Nothing points away from the camera. We have a fisheye lens, is what we have, which is
kind
cool.
of, yeah.
It's cool, but also like not what I want. Like the bottom of the screen still points towards the player, perspective-wise.
Yeah, well, I mean, look, you can see the side of these things, right? You can see quite prominently
the side, but you can't see the far side, and you can see the far side of our trees. Yeah, that's too far. I wonder. I mean,
yeah, I don't know, man.
Yeah, are we just like aiming the camera wrong? Because when you zoom in, it starts to look really good.
I mean, how does this tree look when it's really close up to the camera? Does that look normal to you?
I think it looks more normal than the zoomed out view.
Like we have a distorted parabolas even in this zoomed in view.
Yeah, it's true. Damn.
All right, but before I complain about that, let's talk a little bit about the pathfinding for the builder, right?
Yeah.
So the pathfinding update works now. Just to recap, was this going to do anything if I blow it up? Probably not. I was too slow.
Yep.
It works now. The change was... It was just an ordering thing, right?
Right. We were deleting our wall entities before unindexing, and our unindex for the Pathfinder specifically depended on whether or not the wall property was there. Correct? Yeah.
Yeah, I had to flip those two things around.
Cool.
Right.
But that makes sense. Like operate before deletion if you're going to undelete something, or if you're going to remove it.
It kind of unwraps this in the right order, because when you add these things, like when you register them originally, you add it all in there, and then you index.
Yep.
So it stands to reason that when you unregister something or when you delete it, you do this first, you unindex it, and then you do the rest of the stuff.
Yeah.
Right?
No, absolutely. That seems fine.
Yeah. So that's basically what happened there.
Cool.
Okay. Now, we also were kind of concerned about the fact that, like, when you blow something up, like, because of our rollback networking, you're going to do it at least twice, right? Once during prediction and once during the server reconciliation. And you can actually see that happen if we go to the Pathfinder. And if I turn off caching, recalculating planner, and do you notice this WebGL warning? We'll fix that.
Oh, interesting. Oh, can you we'll make the bottom of the window a little taller? Or sorry, can't see the console. That works.
Yeah. If I reload, you can actually see. You'll see like all these render warnings. I think it might be because debug draw is not working, but we'll see. So if I destroy a wall, let me just whip out the rocket. Ooh, that didn't do what I expected.
Man, those trees on the right look really messed up.
They look pretty messed up.
That's some going through the time vortex trees over there.
Why is this not printing? Well, We should be marking the walls as dirty.
Frame update. Oh, and did I notice that you're checksumming the planner now? Is that a new addition?
Yeah. Oh, you know what? It's printing it on the server side. It's just not. Maybe console.debug just doesn't work.
Might. You might only be looking at. I wonder if you're only looking at log.
Oh, there it is. So recalculate the planner. It's just cancel.debug just doesn't work. It doesn't work in the browser.
Cool.
So if I blow something up, I blow up a wall. You notice how it calculates the planner twice? This is the predicted frame. This is the server frame on the client side when it gets it back, right?
So if you were in like networking mode where we're doing like 10 frames ahead of server, we would see that 10 times until it's real, basically.
I think you would only see it once, or you would only see it twice. You'd see it in the frame that you predicted it. You're right. It might actually happen 10 times.
I think you predict the same frame multiple times. Yeah.
Yeah. Anything that you do reprediction over, you'll see it. Yeah.
Okay.
Okay. So the solution to that is to add a cache, and I'll show you how that works in a second. But if we're now caching it, and I blow something up, we only get recalculating planner once.
Nice.
Yeah. Or recalculating planner. Anyways, you get what I'm saying.
Absolutely. Oh, that's clever. Okay.
So how does the cache work? Well, it's just a cache, right? We look up something. We somehow get the checksum of the grid, and I'll talk about that in a second. We pull the planner out of the cache using the checksum. If we actually got something, then we just use the old cache version.
Nice.
Otherwise, we recalculate the planner using the current grid. And then we set that new version of the planner into the cache using the checksum that we calculated, right?
So if you destroyed a wall and then our builder could build a wall in the same spot, it would actually checksum the same and we revert to an older planner.
It should, yep.
Cool. That's great.
Okay, so first of all, what's the checksum? The checksum is just a CRC32 of the grid data as a uint 8 array.
Nice.
Yeah. This is an ND array.
That's right.
And it has a property called data, and I checked the source code. All this is whatever you pass into the constructor. Right,
because the ND array is giving us just like, we know it's a uint, yeah, and it's giving us handy two-dimensional accessors. Or
correct.
N-dimensional, I guess.
Yeah. I think if you look at this, it's a type data T, which is one of these things, which is.
I think we have one of those in our own code, yeah.
Yeah. But we know it's a uint 8 array based on inside knowledge, basically. We created it here, right? Mm-hmm. CRC32, I grabbed a bunch of different libraries to do this, and then I realized it's actually not that much code. And some of the libraries I was bringing in they had their own dependencies. I'm like, why do you need dependencies for CRC32?
It's the JavaScript way.
Oh yeah, this one. I think this is the one I started with. They got 2 million weekly downloads. That's reputable, right?
It's not bad.
But then you go into here, and you're like, why do you need like print J and exit on epipe?
What the fuck?
And the reason is that this is one of those NPM modules that comes with the CLI tool. And this is what drives the CLI tool. Yeah. I wasn't a fan.
Nope.
Then I looked up like, what's the fastest node hash library, right? And it turns out I found one called Hashwasm. I was like, oh, this is promising, Hashwasm, because like I didn't want to have like a binding around a C library because I couldn't use that in the browser, right? Mm-hmm. So I was like, oh, this sounds really good. But then if you actually go and look at the on how to use this thing, you have to await all the calculation.
Oh no.
The reason being is that it's WASM, right? And WASM has like a separate execution environment, so it's asynchronous.
Yep. So you have to. Okay.
So I don't know what the point of calling this fast is when you have to like defer to the event loop in order to get a response. This seems to me like overwhelmingly much slower than anything you would just have executing directly, right?
Well, right. I
It
feel
sort
like
of stands to reason.
we've experienced some very disappointing event loop performance.
Yeah.
This is not going to help.
Especially for something like SHA-1, right? It's just fast. SHA-1 is fast.
I mean, maybe
so
if you're doing bcrypt with like a high difficulty, maybe this is worth it.
Yeah, then you can just shove it onto a different thread or something like that, right?
Yeah. But like that's already slow. It's supposed to be slow, so you don't need a fast library for it. So I'm not convinced.
Yeah. So I just went on Stack Overflow and just like, how do you do CRC32? I copied it. I got some test vectors to make sure that it worked, and so this is what we've got for our hash function, basically.
Nice. I thought you were gonna say that you just copy this out of a different library, but way to not make our licenses complicated.
So at any rate, I was a little bit nervous that like CRC32 would have a high collision rate, but our cache is only it's only 10 deep.
Nice. Okay.
At least for the Pathfinder, I just said, hey, your capacity is 10.
I was wondering.
I'm not sure what. Awesome. Yeah, I think what we can do is probably we could probably do some metrics on it and see like exactly what is like the oldest thing we ever pull out of the cache, right?
Well, yeah, I was gonna say if it needs to be the depth of our like expected predicted frames at least, right? Because we will, if we have 10 grid updates coming in 10 frames, we'll probably bust and re-simulate those a couple times.
That is a totally reasonable analysis. Yeah.
Yeah. So maybe twice that or 3 times that, but still a very tiny number.
Yeah. So I think. I don't know what the birthday paradox numbers are for CRC30 for like a 32-bit number if you have 20 things. Mm-hmm. The birthday paradox doesn't quite apply with CRC32 because it's not fully random, but I think it may be a reasonable proxy.
Well, and the nice thing is too that we frequently recalculate the path, right? So even if one of them does collide and give a really stale set of pathfinding data, we'll recalculate against something newer in the next 10 frames.
Potentially, it just depends on whether or not something causes the grid to change, right? If somebody builds a wall or destroys it, which might happen fairly frequently, right? Hopefully not too frequently.
I mean, possibly one per player per frame, maximum. I guess turrets can do it.
Yeah, the reconstruction of the grid itself will only ever happen at most once per frame, right? Because this is happening in the frame update.
I like that a lot. I have a dumb question. Nope, that's
sure.
Fine. No, I was gonna say like why aren't we just caching by frame number? But it's because the predicted grid won't match the authoritative grid for that frame, so we can't.
Yeah, and then I think like you said before, like we could potentially like rebuild the wall, and in that case, you might get the exact same map or the exact same grid, but like 1,000 frames later or something like that, right?
Yeah, that LRU cache probably will have already tossed it out, so maybe less important.
Potentially, yeah. The way the LRU works, fun exercise in data structures, actually. It's one of those, like, you need to have 2 internal data structures to get everything that you want kind of thing.
Really? Oh.
Yeah.
I don't think I've ever written one of these.
So basically, the idea is for any cache, you're going to want to have like sort of hash table-y characteristics when you look something up, or at least you want to know if it's in there or not. So that's what the index is in here for. And so when you add something, you basically check to see if it's an index or not. And if it's not, then we basically we add it. And then we also promote the item so that it basically is like the most recently used thing, right? So the 2 data structures are a key value map for looking stuff up, and then a linked list to basically determine the order of our objects. Cool. Right? The linked list might be overkill. I might be able to do something with just like a sorted array because we're only ever going to use this for like 10 things. But the idea behind a linked list is that the thing you care about is if you're at capacity, right? If you've got 10 things and then you add another thing, you're going to want to chuck the lowest priority thing that was already in there, right?
Right.
And that's what happens in this set new function here, where if we've reached capacity, so if we get down here, what we do is we take the tail, we delete that value out of the map, and then we make the thing before that before that tail the new last thing, right? That's basically what happens there.
Cool.
So yeah, this is one of those like data structures where you kind of want to have your cake and eat it too. And because you want to have your cake and eat it too, you need to have like two underlying data structures to satisfy both things, right?
Nice. Yeah, that makes sense. I mean,
okay.
This is cool.
Yeah, I feel like we've wanted this before. Like, I think at one point we wanted to have a priority queue, but we also wanted to be able to like remove things by ID as well.
Oh, yeah.
And we never got around to implementing that, but that would require something similar to this level of complexity, or probably more. But it's a similar idea.
Yep.
Yeah. And interestingly, the thing that you have in the map is actually the linked list node, like a reference to the same linked list node that's in the linked list.
Well, because otherwise you'd have to do a full traversal to do any operation, right?
Yeah. You hit the nail on the head. That's exactly right.
I remember how not to make a n squared or n cubed data structure, and it is do stuff like this.
Right. So I think that having that LRU around will prove useful like in other ways. Like you can imagine that the Pathfinder, maybe we could, right? And the Pathfinder could have a cache on the route and return the path if calculated it. I'm not sure if that's 100% useful because the number of times that you're going to like get the exact pair of, source and destination may be a little bit infrequent. So maybe the number of times that we actually rely on the cache or we get cache hits is going to be relatively low, right?
Yeah. Okay.
And we'd have to clear out this cache every time the grid changed. Right, because the path we have to assume that the paths wouldn't be valid anymore.
Yeah, interesting. And we're not caching that yet, though, right? We are just doing a live.
Yeah,
I was thinking
we're not doing it yet.
I was thinking it might be interesting to. I was thinking about writing the path to the builder component itself, not necessarily for caching, but maybe just so we could like be aiming for its next step, essentially.
Oh, hey, we probably should cache this because for the same reason that we have to calculate the planner twice. I think we're going to end up calling get path twice, right? Because of the reprediction.
Yeah.
Yeah.
Yeah, that'd be nice. Okay.
So maybe we should just cache it.
At least for that, yeah. Yeah, if we can make our repredicted frames a little faster, that is probably worth it.
We're doing something interesting right now where we're actually recalculating the path every frame.
And we spun it up multiplayer, right? It actually was not a huge problem with two of us on the server.
It wasn't a huge problem, but it's definitely something that we don't need to do, right?
Yeah, of course. Yeah, mostly I'm just surprised that.
Yeah, we're just pulling it up multiple times, right?
Yep. Oh yeah, I guess my thought was that I was wondering if we care about recalculating until we get to the next step of the path. So like we're getting these nodes and they're pretty broad, right?
Yep.
I wonder if in the future we would want to maybe not like store the path and move towards the path until you hit that node and then check against your destination again. And maybe if obstacles are in the way or if there's shorter routes, maybe what can be done is to recalculate the path only to your next node to see if there's a shorter one and then throw it out if not.
The reason why you'd want to get the path again is there's two reasons. One is that the grid has changed.
Yeah.
Right. Two is that if somehow the builder deviated from its path for whatever reason, which we don't really have a reason for that ever happening, right?
No, but it could. We have knockback and stuff, so I'm sure something could pull it off course.
Yeah. So I wonder, like, you kind of want the builder to be sort of, it has some set of conditions where it will call this again. Whether the builder gets knocked around, that's something that it probably knows about locally, right? Maybe the component, maybe it has a component, like it has a damageable component that can set a flag or something like that. What you don't know about locally is whether or not the grid has changed. The Pathfinder knows that, but you don't know it locally and around here, right?
Gotcha. Okay. Yeah.
But I mean, there are things that we can do, right? Like, what if we stored this path on the builder? I think you were kind of pointing towards something like that, right?
Well, it's really interesting because what I was trying to think if we could potentially make less work for the algorithm by storing the next step, because we immediately calculate the path and only take values 2 and 3 out of it, no matter what it is. Who the fuck is knocking? God damn it. Sorry about that.
Is that someone like coming to your door?
No, I think it's someone upstairs. Let me I'll be right back.
Sounds good. Sorry, you were saying about the Pathfinder.
Just the only thing in my head is that line 68 here. We disregard almost the entirety of what we've asked it to pathfind for a complex path.
Yeah.
And really just wondering if there's something we can do to take advantage of that fact. Like, should we when we recalculate, should we do a shorter path until we get to the coordinates at 2, 3, and then check the whole path again? And I think that's like maybe not optimal pathfinding behavior in some cases, I can imagine.
Well, we do recalculate the path because like this tile position is constantly getting updated because we're moving it, right? We could
only thinking if there's shorter paths that we could find, or rather, if the length of the path adds to the time complexity of it for the algorithm, right? Like, if we do it in shorter chunks in resimulation, I think we maybe get better results for each tick of repathing, maybe. That's what I'm trying to figure out. Like, if we have like 100 of these going.
How do you do shorter chunks without knowing the entire path, though?
That's what I was thinking. Only step towards the next. Only double check between yourself and the next node that you're walking towards. Like, store the value from 2, 3 on line 68, and when you recalculate, only check that segment from tile pause to that, and then when you get there, like, check the whole path again. But like, for many of our path steps, only recalculating like a tiny portion to make sure we're still. It's like always making sure we're not blocked going where we're going, and then maybe only re-looking for a shorter path occasionally. So I think the behavior I'm describing would not immediately snap around back to the shorter path when you were shooting, but it might 10 frames later.
Right. Well, I think the thing I'm having a hard time getting my head around. You have to know the full path in order to know an intermediate node on the path, right? You have to get the full thing, right?
Yeah. I mean, I was thinking that what we should cache is line 60 or now line 70, but like, we should be writing our next node to the component. Like, that's the value that I think is the most valuable to store, because we can step towards that in simulation until we get to it.
What if we did this?
Yeah.
It was just sort of like a modification of what you're saying, right?
Yeah, I'm not sure my optimization is good. Okay.
We can use the grid checksum as kind of a proxy of the version of the path that we're currently on, right?
Yep. Yeah, because it's interesting too, because right now we just step until the Pathfinder gives us a new node in the second position, right? Like we can't actually tell which segment of the path we're on in terms of 2-point coordinates.
Yeah, I think our old builder did know. Our old builder had the whole path on it, right?
It had the whole path, and it was sort of popping stuff off.
Yeah. So I think some version of this makes sense, where basically we save the entire path on the builder, and then let me actually do the DOM trick there. These are the first two things, right? And then somehow the builder knows like where along that path it is. The problem is that the path might have changed. So we have to kind of check every frame to see if that had happened, right? But we don't want to go as far as like recalculating the entire path, which is what we're doing now, right? Like what we're doing now is we're saying, hey, just take my current position, give me the new path, and do all the complicated stuff, right? But what we could say is, since we're saving the entire path and we know how far along that path we are, we could say, hey, did the grid change at all? Because that's what's going to force you to like give me a new path. And the way that we can check that is we can save on the builder what version of the grid we had when we got that path originally. And only in the case if that changed should we get a new path. Does that make sense?
Yeah, that sounds reasonable.
Are
you also thinking of maintaining the old version? Is there a point of that? I guess for rollbacks we don't do it multiple times. But maybe it's cheap.
Sorry, can you say that one more time?
Yeah. If we're in prediction and there's like, walls deleted on frames 3, 6, and 9. Do we want to do those paths end up cached in a way that like we actually don't have to recalculate that when we hit the same checksum again?
I think we can.
It probably won't be the same checksum though, because like if it's prediction, we'll miss some other wall being destroyed or the other builder going off and doing its thing. So maybe
we could cache in the Pathfinder.
We cache the source destination and checksum.
These are all just like 4 numbers, right?
Yep.
And then we can also cache the checksum along with that.
That sounds pretty good.
Yeah. So we'd be like heavily redundantly cached. And the thing is, I think this cache would have to be much larger than the planner cache.
Yep.
Which starts to get me a little bit nervous about collisions, but
yeah. Well, I mean, let me throw it out there. What if we didn't? Just because we haven't really hit the performance problem yet, and we threw out a bunch of builders that were recalculating every frame still and doing fine.
You're saying just don't cache?
For now, yeah, until we see that like we're having problems.
Well, this is fast. The slow thing is this. So you're right that maybe not caching is fine. Yeah,
well, and I know that one of our sort of potential pitfalls was the builder returning to the player and having to like recalculate every frame. But I feel like we solved that by making it recalculate every frame on the way out too, so it'll be exactly the same cost.
Yeah.
So seems pretty good.
Cool.
Yeah, I'm very down to punt on this until we want to like.
That's totally fine.
And then improve the performance of this to take out a roadblock. We
could maybe change this to CRC 64, and that could be okay. Whatever that looks like. I have a bigger problem with the Pathfinder right now, though.
Oh, great! Yeah.
Gosh, this looks terrible.
What is our OpenGL warning? What happened?
Okay, well maybe we can fix this as well. But let me discuss a problem with you with the Pathfinder. Check this route out.
That's not optimal. Ooh.
It's pretty bad, right? So
is our Pathfinder only giving us nodes? That looks like it has diagonals in it.
A non-diagonal grid is an L1. This does look like it has diagonals, doesn't it?
Yeah, but...
Or is it just really massive?
I was going to say, the actual optimal path would be to do a diagonal line...
right here.
Yeah, and
or diagonal line really right through here.
Exactly. Yeah, so that's not That could be better.
So non-diagonal grid is an L1 grid.
I was going to say this probably has pathfinding nodes on the map too that are maybe not the grid points.
No, this is just a straight grid.
Straight grid? Here. Okay.
Yeah.
Great.
The problem is that a non-diagonal grid is known as an L1 grid. So the graph that you're traversing and that you're searching over is the neighbors are just north, south, east, and west.
Mm-hmm.
However, the name of the library that we're using is called L1 Pathfinder. So I think we might be
shit out of luck.
We might be shit out of luck finding diagonal paths unless we use a different Pathfinder.
Now, can we look at the library real quick? Because I feel like diagonals on or off is like a common cost function parameter that maybe we could change. I didn't actually look at the source code for this too hard. But planner search is pretty limited, ain't it?
Yeah.
Damn. Yeah, okay.
So the way that this library works is that it assumes you can only move certain ways, and it pre-processes the grid into something simpler. Mm-hmm. But making the assumption that you can only move north, south, east, and west. So that pre-processing would probably have to change dramatically.
Okay.
And you're right to say that also the A* heuristic would also change, right? Like the cost function that you're talking about. Yeah, because the cost function for like A*, I think we used the Euclidean distance, which means that we calculate like diagonal distance. Mm-hmm. But there are some A* heuristics that use Manhattan distance, right? So they kind of like add the perimeter of the square that you'd have to traverse in order to get in there. And you can, as you can imagine, those come out with rather different behaviors when they do pathfinding. I'm going to go on a limb and say that this is not an acceptable path for our game. What do you think?
I mean, probably not.
Are we off by one? I think I recall us having this issue before.
Oh, well, I was going to say, I think it's because it's going to go until the path says that that it needs to go to another node. So as soon as you touch.
Oh, okay. Oh, but it looks good. It looks fine.
It looks okay. I think if we're building something, it'll build on the right coordinate because we're going to make it. So at the very least, right. I can deal with that. Right. I'm reading the source code on the one issue about diagonal on this. The library implementer actually seems to think that you can do it in user space, but I'm not sure I believe him. This is the library implementer, right?
The idea is to apply a shear using a linear map. XY is x plus y, x minus y. Then the diagonal shortest path in the XY domain is an L1 shortest path in the warp domain. So you solve the shortest there, and then invert it back to the original domain.
This is some mirror world bullshit. I don't quite understand. Huh. Is it actually we throw a different map in there to calculate? Vertical, I mean, I agree with that one, yeah. Huh.
This is not the easiest thing to reason about.
Yep.
I don't think.
I concur.
Yeah.
Cool. Okay. Yeah, I think we should put on it then.
So what are the alternatives to this? Just really quickly. This person has kind of like a comparison to some other pathfinding algorithms. Pathfinding.js.
No, wait, was that the slower side of the chart or the better side of the chart?
The A* one here is the lowest thing.
That looks good. Yeah. Okay.
Yeah.
I love that it's like multiple orders of magnitude slower than his. I see.
It might be a problem.
There is a loud diagonal in there, which is nice.
Yeah, and then there's also bidirectional, which was kind of
Oh,
cool.
that is cool.
What is a Chebyshev heuristic? Euclidean heuristic.
And what is don't cross corners?
I wish I knew.
Yeah.
Oh, you know what it is? It's probably if you had an obstacle here,
Oh, it would.
it would go around it, right?
Oh, I mean, I kind of like that, to be honest.
Yeah, I agree. Um,
That and whoa. And bidirectional added a nice speed up too, right?
it does. Yeah, that's kind of a funny. This is a clearly a non-optimal path, but you kind of have to be willing to live with it, because that's basically it's probably what the cross corners is doing. Yeah.
Yep.
Or if we got
Nice.
rid of bidirectional, yeah, then it's then it's optimal, I think. Bidirectional, you kind of like sacrifice optimality for speed,
Cool.
which I'd be willing to do. Now, the question is like, if this does no pre-processing, we're kind of in a bad way.
Right, because we really can't afford. Well, what is pathfinding grid matrix? Ain't that?
Does it pre-process? It doesn't even know what algorithm you're using. Well, that's fine. This is fine. Where do you pass in the options about like allowing diagonals?
I think it's that A star finder object. Yeah.
But the finder doesn't know anything about the map yet, right?
Yeah. How you pass it that grid, which is the object that's created above there. Okay. Yeah. So what
Yeah,
is
so
the?
I think this is going to be slow. I think this library will be slow.
Yeah, that sounds reasonable.
The reason why I'm saying that is that if you did pre-processing to make the problem faster, this property would be on the grid and not the finder. Does that make
Fair.
sense?
Yeah. I mean, the heuristic is also on the finder, which does not bode well for calculating anything. So yeah.
Yeah.
Uh,
So I think we might be in a situation where there's actually a couple different things that come to mind. Let me also quickly give you an example. All of this is prefaced to say I won't build it up any longer. I think we'll eventually want to roll our own. Not that I'm like being a masochist and like I enjoy the idea of that. But there are certain things that are non-optimal about Pathfinder. Obviously, like it only does it doesn't do diagonals. But also the way in which it doesn't do diagonals is also I think interesting to think about.
I was gonna say we rolled our own, so we can do it again.
Yeah. I think the other thing I'm thinking about, maybe I can just open up a paint program of some kind. What do I have for paint? I have Pixelmator.
As I say, there's Mac Paint is dead, and you've got no Microsoft. Oh, come on, Pixelmator.
And I'm just getting upsold all the time. I have like a lifetime thing, but
that's rude.
Yeah. So if we did a grid, what does this look like when I paint? Like if we did a grid, even if we allowed diagonals, we'd always be moving at 45-degree angles or 90-degree angles, right? We'd always be doing this kind of thing. But wouldn't we want to be doing this as well?
I know what you're about to say. Yeah.
Yeah.
Yep. Yeah, I was wondering about that.
So it kind of makes me think that there is a solution out there. How do I make shapes? What do you think? Is that this? That's the paint bucket.
Well, I was gonna say, it sure sounds like
gradient.
Whoa! It sure sounds like you're about to do a little ray casting to me. Because we can check any two path points and see if you can just walk straight from one to the other.
Ooh, I didn't even think about that.
Cool. Well, and that's a tool we have in our tool belt right now too, to move towards something.
Yeah.
We have a pretty fast raycast, I think.
There's got to be like a draw shapes thing, right?
So I bet it's the shortcut U. What does the letter U bring up for you?
I
Nope.
get like a funny sound effect.
Damn. Is it the heart at the very bottom next to the text, or is that an emoji?
Oh, you're right. Holy crap. You're a genius.
I'm really good at interpreting other people's weird UIs.
Yeah. So I think we might be able to. Ooh, gradient fill. This is very pretty. Oh, what? Oh my gosh. I think.
Rename this the Pixelmator tutorial stream.
Yeah. Oh, I see what's going on here. I wonder if we'd be able to kind of decompose our map into graph nodes that sort of resemble this kind of thing.
Now, isn't this the concept of like pathfinding nodes or navigation nodes? Like it is.
That's exactly right. Yeah.
Yeah, that's what this is.
Sort of a nav mesh sort of thing. And you can imagine that if you're anywhere inside of this area, you'd know that you were in one continuous area. And the way that you would move from point A to point B within this thing is to just take a direct straight line. Does that make sense?
Absolutely.
Which means you would get the severe, like, kind of like, you'd get like the 70-degree angle move, right?
And the problem being, as soon as someone puts a wall anywhere in that nav mesh gets split.
It would get split somehow.
Okay.
Yeah. So the idea is like, how do you go from, let's say you're here, you're like in the upper left, you're in the northeastern corner of the orange tile, and you want to get to the southwestern corner of the green tile, right? The A-star Pathfinder, what it would do is would say, okay, well, you need to go from like, is there some way that we can subdivide the problem so that like the actual pathfind, the search algorithm just uses these giant tiles as the graph nodes, and so the search space is going to be way smaller, right? Rather than searching like a 4,096 tile space, it's only like a 100 graph node space, and then the pathfinding is trivial, right?
Well, so you should know. I mean, we should have like a adjacency graph, so you should know what's next to you and its dimensions.
Right.
That seems doable.
Yeah, I think though that my picture is deceptive because I don't think you can have something like this. I don't think this works because the distance function, it's going to matter like where in the orange tile you are, right? Whether you go through the black and white tile or whether you go directly into the blue tile, right? So I don't think you can have like adjacency graphs that look like this.
Gotcha.
Because the distance function is going to be like, it's going to have to be calculated from like where you are here. So I think there is going to be some notion of alignment where these are actually going to be kind of lined up with each other, I think. And if you had two things that were next to each other like that, that would subdivide into something like this. Does this make sense?
Oh yeah, well, I think it's safe to say that these are probably tile aligned anyway. So yeah. Whoa.
Right. So you wouldn't have.
Now, if you put a wall in the middle of that green field.
Okay. Yeah. Let's say we've got the wall, and let me actually just draw it, and let's make it black. Right.
Yeah.
Ooh, how do I order this?
I don't know.
Layer, bring forward.
Bring to front. All the way. Let's see.
Bring to front. Yeah.
So how many subdivisions does the green block now have? Is it 8?
I think it'd be this one.
Uh-huh.
It would actually be
I think
what it
actually
would be.
four is the minimum. Yeah.
I think based on what I just said, what am I? How do
I don't think that's a drag. Try the corners. Yeah.
I think we would need this.
Okay.
And then we would need this. Let me use a different color for this other one.
You can make them all green because I feel like this is sort of what green turned into. I think that'll be helpful.
Okay, you've got an idea of what I'm going for though, right here, right? You got this.
I'm curious. Yeah.
You got this. I think I have to click this every single time. You got this.
You write option drag on one of those if you want to.
Oh, you're right. Then I'd have to resize, right? And whatever this used to be, right?
Now, my question is, can the top and bottom be actually single? Instead of being three separate nodes, can they be a single one?
Ooh. Yeah, let's think about that one. Let me just flesh this out real quick.
Yep. And then if you delete the black one, I feel like that's actually our nav mesh, which is there's a chunk missing.
Oh, right, because this is a wall, right? And because this is a wall, all three of these could be the same.
Exactly.
Well,
it's you can't navigate through it, so it's not. It doesn't need to subdivide its neighbors. Is that correct?
So if you're inside this greater rectangle along the top, and you wanted to get down here, this lower rectangle here, how do you know whether to go around this way or to go around this way?
I think it probably searches both and does something very A-star like to get there.
Oh, right, because you have different edges.
Yep.
But the problem is that unless you subdivide this top thing into the three sectors that it has right now, the distance function from this rectangle to this one down here and to this one down here, it doesn't know where inside of this larger rectangle to start the calculation from.
But isn't that true for even when subdivided? Because if you're in the blue one, how do you decide which of the three green ones to go into that are adjacent to it?
That's a good question.
Yeah, I think we have to solve that problem no matter what. But when solved is okay. I think what you do is you probably take aim at your neighbors, and if I'm in the center of the blue square, you aim at each neighbor, draw three lines, and that's your path. Yeah.
So it's almost as if the edge to your neighbor is actually not constant. It's where are you in your current node? Draw a line to the midpoint of the border between you and your neighbor, and that's the cost of your first edge, something like that.
Yeah, I think so. That's interesting.
Yeah, it is. This has been solved because this is basically what a nav mesh does, right? Cool. Nav meshes, they do this, and we'd have to look it up. We'd have to do some research. But this is more or less what they do, and I think what we're talking about is automating the creation of what is more or less a less granular grid or less granular graph, because the granularity of our graph right now is insane, right? It's there's one node per tile.
Yeah, and it's funny because when I think about,
which means that when we pathfind from this open space to this other open space here, it's ridiculous the amount of extra stuff we have to. Yeah, right.
Yeah, I was thinking it was a little silly because if you add enough walls or colliders, will it actually be an improvement? But I think kind of de facto it will. Yeah. And I wonder too if we did. Do you remember the very silly? Remember that Bolo map that's just a spiral of walls? I feel like that actually maps to this well as well.
Yeah, I know what you mean.
Yeah.
So Red Blob games, they have so many. We talked a little bit about this this site last time or the time before. He's got a bunch of pages about the pathfinding problem, and you'll notice that the graph that they composed here is not really one of like nav tiles, which is what we drew in Pixelmator, but instead it's like it's like points where you have to make a decision. I don't know how to describe that idea mathematically, but the graph is actually fully described here, right? You notice
really
how much smaller. You notice how much smaller this graph is relative to the number of actual navigable tiles, right? This is a major improvement, right?
Huh. So if you wanted to navigate to the top right of that map, like one of those gray tiles up there.
Yeah.
Is it you find the closest? You just like distance search the closest nav node, and then use the nav map to get you there from wherever else you are.
Can you say that one more time?
How? Yeah. If I want to navigate there, how do I determine which node to go to? Like, there's a node sort of below it. How do I know that that's the one I step off of the grid, the mesh from to get to?
It's a good question. Let's say you're on the opposite side of the map, right?
Yeah.
And so it's basically, am I pathfinding to this node, or to this node? Right? How does it know which one of those to pick?
Yeah.
That's a good question, because I think it probably picks the one with the lowest distance, and then maybe then assumes that you just take a straight line from that point to wherever you wanted to go in this area. But that might not be the actual best path, right? The best path might have been you going to this longer, maybe like a longer route to a less optimal node, but it ends up being closer in this whole area to where you wanted to go, right? That's basically what you were getting at.
That's what I was wondering, yeah. But also,
and by the way, we'd have to solve that problem with this thing as well.
Exactly, right? Yeah. This seems good actually, because basically that line movement makes two checks. The check one is like, am I moving to a thing that is blocked, and it's got the grid representation for that, and that's just a constant check. And then it has the step to like pick my destination or my target and my destination, and like do a quick search to figure out what the closest nodes are and navigate between them. That's not bad.
Yeah. And I guess, to be totally honest, like, as long as it feels reasonable, it doesn't have to be correct. But unfortunately, I think there's probably going to be like a lot of these are like about taking shortcuts. And
I was going to say optimal pathfinding is unnecessary. Yeah. Huh. Okay.
Okay. So all that being, I think all of this was to say that like we found this like super cool. Did I really want to close that? I probably didn't, but whatever. We found this super cool library that does this quickly, but it doesn't feel very game-like. Right?
Yep. And I guess I was also wondering just if we'd want to actually take a peek into its source code and cost function and pre-process it and sort of see if we think it's modifiable.
Right. Boy, this cube on the end there.
It's rough.
Look how tall it is.
The cube, the trees are just like smeared onto the ground. Yeah.
So basically, the higher something is on the y-axis, the more distorted it becomes. Right. All right. Well. So I keep getting distracted by this, but we're talking about two interesting, difficult problems to solve.
Yeah.
One is this camera thing, and the other is this like what Pathfinder thing do we use? And
well,
so you're saying let's take a look at the source code and see what they're doing. Is that what you're proposing?
I'm kind of curious if there's even a jumping off point for this sucker that is useful.
Right.
I wonder. I'm not sure.
So L1 Pathfinder preprocesses the grid to extract a visibility graph.
Mm-hmm.
This is a visibility graph, I guess.
That looks a lot like what we were talking about.
It does, although I think this visibility graph assumes L1 movement.
Ah, okay. Interesting.
Which is why I think it might be hard to like bespoke spin something out of this library, because I think
Gotcha.
the idea of grid movement is built into the preprocessing. Does that make sense?
Mm-hmm.
However, this person is saying that there's a way to calculate waypoints if you assume diagonal motion, right?
Cool. Okay.
And there might even be a way to like trim out this edge here, because this edge maybe shouldn't be possible.
It's
It mean you're cheating around the corner, right?
I guess so. Yeah, it's a little iffy. Oh, right,
Okay, but that wouldn't be the
most
worst
of
thing in the world if
most of the
that was in the
motion through
game.
corners are straight lines here. Yeah. Right.
Yeah. Waypoints. So
I
how do
accept
we?
that one. Yeah.
So waypoints are the key decision points where you might have to change direction. In the above diagram, I mark places where you have to go around the corner or a wall. I call these exterior corners. So how do you do exterior corner detection in an automated way? There are multiple algorithms in computer science literature that can improve pathfinding for grid maps with grid L1 movement. We already are not interested in L1, right? We've already decided that L1 is not for us. We don't want paths that look like this. It looks goofy, right?
I would take paths that look like that if it was doing diagonal stepping.
I see what you're saying.
If it
Like,
was doing that stepping, that would still be cool, but it's not. Our grid movement is like, I mean, that's what's weird to me, right? Is it if you go 45, if you shoot the builder 45 degrees up, does it move
yeah,
all the way X, then all the way Y?
I think the shape of the path. So there's this notion of equivalence in pathfinding algorithms where, like, the optimal path, if you're talking about L1 movement, which is what this is doing, there's actually like a ton of optimal paths, right? You could go like this, or you could do a zigzaggy thing, which is what you're proposing is better.
It would look better.
And or you could do this weird, crazy thing, right? You could do something wacky.
Yep.
Like how your algorithm actually chooses that is like an emergent behavior, like a lot of different factors.
Right, because without diagonal movement, it is the exact same rise over run, no matter what. Period.
Right.
Okay.
The Manhattan distance is going to be the same.
Yeah. Okay.
So I think unless this algorithm has a way for us, and actually, you know, it's kind of funny. This person also talks about like a bunch of ways of like modifying the shape of your path. I forget. He's got like 50 million pages. This could be organized better. I confess. But how do you do waypoint derivation? Waypoints. How did he come up with this graph, right?
That's what I want to know.
And intellectually, he calls them exterior corners. Like, can you, just by eyeballing this, is there any wisdom that comes out of just like staring at this? Oh shit! He's clearly automating it because you're taking stuff away.
Yeah. Dude, that's what I love about everything on this site is that you can click every graph. It's a little bonkers.
So what is causing this to change? He's got to have his source code somewhere, right?
Is it not linked here? I thought it was. Yeah. Shit.
Links.
Whoa. Pinboard. Oof.
Good old pinboard it used to be pinboard.in, right? In.
Yeah, I remember those days. I remember using Pinboard. It's been a while.
It's been a while, yeah. I used to work at If This Then That, and our Pinboard connection was popular, but then we changed the way that the platform worked, and the proprietor of Pinboard got very angry at us.
You know, he gets very angry.
Very publicly shamed us on the internet, which we felt bad about.
You know, I used to think that he was like cool Twitter dude. I just think he's a bitter old man. I am not. I am not a fan of Moncheck the Pinboard guy. Yeah. Surely there's a GitHub. Yeah.
Oh yeah.
Now we're talking. Bring it on.
All right, 21 repositories. Let's roll the dice here.
Mapgen 2025 roguelike dev. He's in the future.
Bummer.
Thanks a lot.
Well, look, we're smart people here. We can.
Yeah. We can steal the source code from his website just fine.
Gosh. Okay.
So I did notice, and it was crossing my mind too, that like one of the data structures he suggests is a quad tree, which we have.
We do have a quad tree.
Yeah.
And now when I think quad tree, I think I was like, should I have closed Pixelmator? I think that basically like a quad tree is close to how you might consider doing the subdivision. A quad tree is all squares.
Right, exactly. So I was actually thinking if it was subdivision by ones, subdivision by like unit of one, your quad tree might actually be the correct way to represent
what
that.
Would your algorithm for generating a quad tree be if you had walls?
Yeah, that's a good question.
Yeah. All right, so bear with me here. We're going to do a little bit of hacking because we're hackers.
Let's do it.
Okay, so this thing here is called Waypoints line.
Okay.
So I'm guessing this is where his click handler is going, right?
No, does it have any class at all? Nope. Okay. Yeah. Yeah.
Canvas. Yeah.
Yeah.
So it's going to be the canvas under Waypoints line, right? And then where do you think his source code is? Algorithms.js?
I just play the network tab. If it's JavaScript, it should be at the bottom of the page for one thing. If he cares about
sources, perhaps.
But yeah, I hit sources.
Pathfinding. JS.
I think from in here, can you Command F to search all files? Because you're looking for that class, right? Or the ID? Yeah.
Was it Waypoints line?
I think so. Yeah, it sounds right.
And it would likely have a hash in front of it.
Not necessarily.
Or would there be a get element by there would be a get element by ID?
Yeah.
Something like that. What's in this? Delanator.
Well, yeah, you can check all these files for that at least. Yeah.
Oh, I see. So it's like a file by file.
I guess it's file by file. Yeah, I was thinking it would do all resources, but seemingly no.
That's fine.
Yeah.
Whatever. I if there's one thing I can do in programming, it's do like fucking brute force shit like this.
Here we go.
New diagram, waypoints line, shared graph, options layout, layers base, layers editable. There's a lot of abstractions going on here. What's a diagram?
Actually, you know what?
Oh, yes.
I can do it too. I got control. I've moved the source code ever so slightly. That works.
Okay. Subgraph layer node waypoints. What is node waypoints?
Okay.
Oh. Well, hell, look at this. He just calculates the exterior corners. But you also want to know the connections. First of all, what's a graph? I guess that's a good thing to understand.
Well, yeah. And how is he? Yeah, how is he telling which exterior corners can see each other?
Oh.
The hackiest. I love this.
Yeah, don't you? So the graph is a square grid.
Mm-hmm.
Which It has width and height, the number of nodes, and edges.
No, number of nodes and edges are the same size right now? What's up with that? It's got 216 nodes, 216 edges.
Yeah, you would think that there would be more edges than nodes, right?
I would. It'd be weird if that is a coincidence. Oh, this is 216. This is an array for every node, every graph tile and a adjacency list of its neighbors.
So is 118
Means that
the
node
tile?
one, tile 1 is adjacent to tile 18, yeah. Yep.
Oh, so what does 219.0 mean?
Tile 2. Oh, maybe that is tile 0 is adjacent to 1 and 18. Tile 1 is adjacent to 2, 0, and 19.
Oh, that makes total sense. Yeah. Because you can see that there's pairs here, right?
Yep.
0 is adjacent to 1, and 1 is adjacent to 0.
Yep.
And let's look at 18, right? 18 should have 0 in there, right? And it does.
That's a cute little data structure. Cool.
Okay, yeah. It is literally the adjacency list.
Mm-hmm.
You were correct. So what this does here is presumably it returns points.
Mm-hmm.
Points is an array. And what is an exterior corner? An exterior corner is an element in tiles. And tiles is a pairwise, it's a tuple. It's a two-tuple, right?
Hmm.
So this just gives us a list of the tiles. How does the graph know? Oh, let's just reason about this. So basically, he's going over like grid-wise element, like tile by tile, right? Mm-hmm. So we're gonna look in this tile here. Is 12 times 18 216?
Yes.
Why would these ever drift from each other? Do you think?
Where do they drift?
Why would you store both num nodes and H and W at the same time?
Oh, well, you probably do you eliminate nodes as they are blocked? If a node is a wall, do you take it out? Is that helpful information? I guess it won't show up.
I think it's literally just a cache over the multiplication of H and W.
That seems excessive. But maybe,
how many times does he call this? Let me jump through and see if this is
that's
if there like deviates from our expectations. Doesn't look like it.
I just realized that I might run out of battery power. Let me sort that out. I've been doing this whole stream on a laptop at 60 FPS, and it's just been on battery this whole damn time.
Amazing.
It's pretty good, actually.
Yeah, great value. What a bargain.
Okay, wait. You keep sending me the source code. 1 sec. I'm gonna steal power cord.
Yeah.
I'm gonna be the one who has to edit it. I'm gonna have to edit in a bunch of SpongeBob pictures on this one.
You could just keep it in there. I'm sure historians would value my facial expressions while I'm the only one on stream.
I can't wait to see what you told the world when I wasn't here.
Okay, so this is just marching through the graph tile by tile.
Mm-hmm.
Is this legible, by the way? Can you read this? Should I bump it up?
I can, and I'm looking at it actually in a window on a window, so seems good.
Okay.
Yeah, I'm watching this through OBS.
Maybe this will be better. What do you think?
Oh yeah.
It's a gamble, but it looks better.
Mm-hmm.
We march through tile by tile. This is our classic nested loop. Interestingly, he's going columns first, then rows, but it doesn't matter because he's got it labeled X and Y.
Mm-hmm.
We get all the neighbors here. How does he know if we don't leak over the side? Like, is he going to count invalid nodes here? And maybe it doesn't matter. So then we iterate over all four of these things, right? And if occupied, graph tiles I. So if there's a wall there, that's what I'm guessing.
Mm-hmm. Mm-hmm.
We increment count.
What is count?
Count is just a variable that, so basically it could be up to the number 4, right? And the last one that was occupied, we keep record of. And if the count is 1, so if basically what they're saying is like among these 4 tiles, if only one of them is occupied.
Then we're a corner.
Yes.
Okay.
And the corner among those is whatever the last one was plus 2 modulo 4. So imagine that this was repeating itself over and over again, right? Mm-hmm. So we basically increment 2, and that's the exterior. That's like the external corner, right?
That is a.
Okay. Before we think about that too deeply, I just want to know where they're going with this, right? And if it's not already added, we go ahead and add it, and then we add that point.
Okay. So it's stepping through the entire graph and finding nodes that are bordered by exactly one.
Yeah.
And
so if you add,
it's actually not bordered.
I think what we're doing is we're basically picking the diagonal thing to the one that was filled in, right?
Right. Actually, wait. Can you go back to the code real quick? Because the way that it picks tiles here is what really interests me. Because he does the one you're on, and then x plus 1 y. Like these aren't. This isn't the full set of diagonals. It's diagonals in a direction.
Can you say diagonals one more time?
Diagonals. He's not looking at the 9 tiles or the 8 tiles around a center, but actually, is it just it's the fan? It's like a fan out from like the direction he's processing the graph. Because you couldn't have an external corner between you couldn't have a gap between nodes and an external corner with only one occupied neighbor unless you only checked some of the nodes.
Right. So if we take a look at the actual code, if we take a look at the actual graph, what to me this is saying, like this last plus 2 mod 4, it's just basically saying let's move ahead twice in this list, and what it's doing is it's picking the diagonal corner from the one that was filled in, right? So if this one was filled in, we'd move ahead 2.
Yep.
To this one. Does that make sense?
Yeah, totally.
Yeah. So what that tells me is it's basically saying for every 4 tiles square, if there's only one thing filled in, then the thing diagonal to that in that 4 tile square is in the list of exterior corners.
Okay. Right? Knowing that, can we attack the algorithm?
Let's take a look at this. Is that true, right? Yeah. Like if you pick any 4 tile square that's on this graph that has one tile in it, then the thing that's diagonal to that filled in tile, that filled in the wall basically, should have a dot on it, right?
Yep.
And I think that's largely true, right? I'm just giving it the eye test right now.
Yeah. Yeah, that does make sense. Let's take the top in the top left section of this. There's that
Here,
the first external node we hit basically.
this
Yeah.
one. Yeah,
If you fill in the square right above that, what is the map
it should
turn
go
into?
away.
It adds more. Okay,
It
sure.
adds more.
Sure.
Yeah.
I am totally down with that. Okay,
And
great.
this one remains filled in because you can draw this square.
Correct. That's
Right?
still true. Uh-huh.
Yeah. Okay.
Okay.
That's pretty rad. Okay, and then the question is like, well, then how is he connecting them, right? Like, how does he know? If he's picked these, he still needs to know like how they connect with each other, right?
Yeah. Right.
And when he creates this thing, the subgraph layer, he's also passing in this thing, edges Delaunay,
hmm
and keep line of sight.
Okay.
Um, does the name Delaunay make any sense to you?
Sadly, no.
Are you familiar with the Voronoi diagram? You'll know it when you see it, actually.
Oh, yes, I am. Huh.
The Voronoi, I actually don't quite know how to describe this, so this is gonna be a little bit embarrassing. But basically, I think what they've done is everything that's like like this the colorization is the result of the Voronoi algorithm. The dots are the source input. And what the colorization is doing is it's basically showing you the neighborhood of points that are closest to the same dot, right? So basically everything that's like bright green here,
hmm
its closest dot is this one right here.
Yep. Yep.
And everything that's kind of like dark blue here, you can't even see it probably, but there's a dot right there where the pointer is. Like
Mhm.
everything that's dark blue here, its closest point is here,
Cool.
right? Does that more or less make sense?
Oh yeah, totally. That's a really cool way to represent that.
And then the Delaunay triangulation is the inverse of this. So apparently these are all duals. This one I've always had a hard about, and both of these things I've never written an algorithm to generate. So like it's beyond me what they actually function as. But I think there's something in this algorithm that he's using to kind of like figure out like these edges here, right? Because
Neat.
somehow it matters to him. Edges Delaunay is this thing here, right? So he's doing a Delaunay triangulation and then picking edges somehow. Oh, and then there's a filter here. Keep line of sight. Keep only edges that have line of sight. So this is the raycasting that you're talking about.
Cool. I was right. Fuck yeah.
Yeah.
That makes sense. I mean, I think I kind of grok that because once you can get to a fewer number of points, like our raycast is not super expensive, and you just run with it.
Yeah. So my question is, for our game
Mhm.
and for the complexity of maps that we may eventually have,
Mhm.
how expensive is it to do all these three things every time the map gets updated? If we cache.
I mean, I was gonna say to do it once per frame doesn't seem that bad.
Yeah, potentially not that bad, right?
Yeah.
And then once we have this, does this buy us what we want if we're trying to do A star, right?
I think it
Like,
does.
so if we wanted to pathfind from, let's say, this point here,
Mhm.
and you wanted to go to like the northeast corner, so you wanted to go from like this down here to up here.
Mhm.
How do you know how do you start
That's
doing A
my
star?
big question. I feel like
Yeah.
you must like when you're there, you no matter where you are on the map, you have clear line of sight to like at least one
Yeah.
point. So figuring out how to get there is weird, but seems doable. And once you get there, you're golden.
Let us say that when we do pre-processing, not only do we have this grid of dots and lines, I think we also have a secondary grid. And then for each one of these tiles, we have a list of which of these dots you have a clear line of sight to, right? That's something that we could do in pre-processing, right?
Interesting. Yeah. Yep.
That seems like relatively trivial to calculate.
Yeah,
Right?
well, I wonder too if there's like I could see the pre-processing. I could also see keeping a quad tree of sorts to like ask for what some nodes near me are. Like if I'm in this bottom right quadrant, what are my navigation nodes and which one's the closest to me that I can see straight?
Yeah.
I don't know which one will be faster.
Right.
I was actually thinking too. A quad tree might be a nice solution. Actually, not necessarily quad tree, but maybe we could actually break this up into subgraphs that are like a ninth of the map or something, and do nine tiles of pathfinding nodes, such that when you update a wall, we only need to like recalculate a chunk of it.
Yeah. But you'd want to know the problem with the quad tree is it's not going to necessarily differentiate between.
Quad tree might be wrong, I think, because like for optimizing this, we only want to know that like a checksum of a chunk of data hasn't changed. The quad tree will keep subdividing. I think we just want to like be able to say the one chunk of our map we're looking at is still the same chunk.
Right.
So subdividing the map to make recalculation faster or like less costly.
Right. Yeah. Okay. Let me give you another fictitious scenario just so we can think about it a little bit. Let's say we want to go from northwest to northeast. What prevents it? Like, first of all, like we're in the northwest. Do you pick this one or do you pick this one to start?
Sure. Yeah.
And then
Great question.
or do you try to pathfind? Let's say like the north. Let's say you have the list I was talking about, and you know where you want to go, and therefore you have in the northeast 3 potential waypoints that you could end up in, and then in the northwest you have 2 potential waypoints that you can start at. Do you simply do 2 times 3 6 pathfindings in a row? Pick the best one and then draw a straight line to the source that is the best?
I mean, wouldn't you just run A star with like the distance is the cost function? So you just run A star, right? Like the distance from wherever you are in the left quadrant to each of your nodes has a different cost, and it's how far you are.
Oh yeah, you're
Like
absolutely right.
you
Yeah,
just
so you basically
yeah.
Sorry, go ahead.
No, the algorithm I think just works if we use distance. Yeah.
I see what you're saying. So what you're saying is you add a fake point that's not in your waypoint list, which is where you start,
Yep.
and you
where
add
you end.
another point, which is where you end. Connect those two things. Make sure you have a way of connecting those two things to the graph, and then just run A star over it. I think that's our algorithm.
Yeah,
I think
I
you
like
just
that.
described it. Yeah.
Sweet. Yeah, I wonder too if like actually maybe even simpler is we start where we are and see what we can. I guess I'm wondering how much raycasting we can do. The less the better live probably.
Sorry, can you say that one more time? You cut out for a second.
Oh, sure. I was just trying to figure out like how much raycasting we would actually want to do, and I think the answer is maybe 0 when we're going live. Only for pre-processing, but
Only for pre-processing. Yes.
Not as part of pathfinding. Yeah.
Oh yeah, absolutely.
Yeah. Cool.
And so I actually think that there's like 3 difficult things, right? In maybe the new Pathfinder. Do diagonals. So our pre-processing is what? We want a list of waypoints, exterior corners. That algorithm, I think we can pretty much grok, right?
I liked it. Yeah, simple enough to understand.
Connect waypoints by line of sight. For every non-waypoint open tile, get list of Does this one make sense?
For every non, yep, absolutely. And I wonder too, like, Yeah, that we can probably start optimizing that based on like distance too.
Mm-hmm.
Like since everything's tile coordinates, we can probably find the closest ones first and check, and then sort of fan out from there. That feels the most expensive to me.
It does. I was about to say the exact same thing. This potentially seems like the most fraught thing.
I wonder if we can avoid processing every tile like that. They don't really give us an answer for how they do it otherwise, do they?
Yeah, I mean, there's no pathfinding going on here, so this is just the reduction. So I guess the question is like, where do you go for like? There's a missing story here where we need to jump from this to actually doing something practical.
Mm-hmm.
So one idea that I have is to do this lazily and cache it, which is to say, like, you don't have to do this for every single tile. Maybe you just like when you actually do need to pathfind, you do it for that tile.
Yeah, that makes sense. Huh. What is the bottom half of this article saying? I forget.
Harness the grid structure.
Yeah, this is just about getting jump point search jumps ahead in the.
So jump point search is I think an alternative to A star, or like you can actually see these are like Baldur's Gate maps.
Yep.
What is RSR? JPS is called jump point search. I don't know what RSR is. RSR is rectangular symmetry reduction.
Holy shit.
But you can see the red is the search space, right? With jump point search here, you can see that they're able to do like really, really fast pathfinding here. Now, I'm not sure if they're doing true diagonals here. I'm not sure what's going on here, but like you can see they're just like A star straight up. This looks like a very familiar, right? This is what our game looked like.
Yeah, exactly.
Yeah. And with RSR, the search space is like it's kind of following walls. It's doing something more intelligent. And then with jump point search, they're able to do something very, very. You can see that it's non-contiguous, so they're almost like scanning for when you hit jump points, I suppose. Maybe jump points are similar to our idea of waypoints. Is that possible?
That's what I'm wondering, yeah.
Yeah.
Okay.
Okay. So we were saying that this seems dicey, right? Actual search. Extend graph with source and destination.
And then A star. Yep. Cool.
Maybe figure out a way to not cheat around corners.
Are we gonna? Isn't this algorithm specifically about not cheating corners, though?
You might be right. Let's take a look at these diagrams.
Back from this page. Nope. Yeah.
Yeah, actually, you wouldn't cheat around a corner if the exterior corners are. You'd have to hit each of the. You'd have to hit these blue points, right, to go around the corners.
Exactly. Yeah. So this one doesn't cheat, which is great.
Right. You couldn't jump these two corners because you'd have to go through the blue one. This is great. We just have to do this super non-trivial thing here.
No pressure. But like also no pressure. We can do it.
Okay. So let me drill down on this question real quick. Yeah. How do we connect waypoints by line of sight without it being n squared? Or is it being n squared fine because we've reduced the number of nodes tremendously?
That's a great question. Yeah, right. Because like what is the total number of rays casted? Much smaller.
Yeah. How is he doing line of sight anyways? And what graph are we actually seeing here?
Keep line of sight. I do wonder, like our ray casting is doing some. We're doing like hitbox stuff, and like it's probably simplifiable on a grid.
edges for each line. You add the endpoints.
Mm-hmm. So they have this draw line function which just returns points. And then it checks it against every graph tile to say, are you not a wall? So draw line is what's generating the, that's the ray essentially.
Okay, and so this is like a bunch of,
it's a bunch of,
it's
like,
basically a bunch of points, right?
coordinate pairs for tiles, and then it tosses them all into, yeah.
Okay, yeah. So this is just a straight up recast.
Mm-hmm. Yeah, optimized for the hit detection is very easy, I guess. Like, not a lot of math there. Just check the graph, make sure
Not
it's
too
not a wall.
bad.
Yeah.
And so is this n squared on the number of nodes in the graph?
The number of nodes in the corner graph, I think so. Yeah.
It kind of has to be, right?
Yeah.
There's nothing that sophisticated.
Right. Though, is there any reason that, like, you'd be able to cut something out? Like, once you can see 2 or 3 neighbors, how many more could you possibly be able to see? I don't know.
That's a good question. I think that would be a matter of like generating a bunch of edge cases in the exterior corners algorithm. I think.
Yeah. Yep. But also, like, n squared and like that graph they've got is, like, it's huge.
The only
20
optimization
nodes, right?
I can think of is that like if you're visible, you're obviously visible the other way, so it's n squared over 2, right?
Yep, that's true. Making sure that works would be nice. Yeah.
I mean, it might not be bad if I don't know how many have we got here. There's probably like 4, 8. That's 5, 13, 15, 17. 17 times 16 divided by 2. It's like 136 raycasts per calculation.
Is that terrible or is that doable? I think that's doable. Our map is bigger.
Our map is bigger, potentially not as complicated, but we don't really know.
Yeah. We have some longer sightlines, though.
Yeah.
You'll probably be doing more checks. That's
Some of this
interesting.
stuff, and we can't do this step lazily, right? Because
That's the graph. That's the edges. Yeah.
that's the graph, yeah. You need to have the full graph to be able to do the pathfinding.
Well, this I maybe.
I think we should just do it and see, right?
I think we should do it and see. This also still makes me think about subdividing the graph into quadrants, into ninths, where you maybe only have to redo a chunk of it and then recast only the nodes that could see into your quadrant before. So you can do like a smaller set of updates, maybe.
The problem with the quadrant visibility is you don't know if there's like walls inside the quadrant. Like I think a quad tree.
I think you have to do all the raycasting, but I think you can sort of not. If I'm in quadrant 1 and I can see a node in quadrant 4, I don't actually have to check all the way out there. I just have to make sure that nothing obscured. If I can still see that from, if I can still see quadrant 4 and there's no wall in my new quadrant, I can like stop. I don't know. It's only optimization though. I think we should try it first and then see if we need to figure out how to subdivide.
Yeah,
it would just be caching parts of it.
So I think if we do some kind of like spatial subdivision, like what you're talking about,
Yeah.
I think it has to be kind of aware of where the walls are. I think just dividing the graph into 4 without considering where the walls are, there might be weird edge cases that make it difficult to use generally, but
Okay. Yeah, I guess my question is, yeah, is there a way to subdivide such that we can update only a part at a time,
right.
and then recalculate its connections to its neighbors eagerly, but like not the entire graph. So whatever subdivision method that takes, really.
Going to Manchester, we have a lot of exterior corners, right? Like we'd have one here, we'd have one here, we'd have one here,
And
one here.
yeah, there's corners everywhere, basically. Yeah.
There's lots of corners depending on what the walls look like, right? Yeah, this would have a ton, right? There'd be one here, there'd be one here, there'd be one.
Yeah. I think it's still doable.
I think so too. The raycast also doesn't have to go all the way, right? Like as soon as you hit a wall, you're basically blocked, right?
Yeah, we can try to stop. We can early out as fast as we can. Yep.
And maybe like if there's somehow we could cheaply keep track of a list of like wide open squares, that's where we could just like have the raycast jump way across, right?
Yeah, the only reason I am cagey on that is that, like, since we're talking about the builder, we can sort of like we're in position to optimally fuck up our map sort of by design, right? Like
we're in position to optimally what?
Like as the player, we can create worst case scenarios for our pathfinding by just building shit in our wide open spaces to fracture
That's right.
whatever optimization we pick for that, which is what worries me a little bit.
Yeah, I see what you're saying.
Yeah.
Anytime we sort of like have to keep a list of wide open spaces, basically any kind of like optimized spatial representation, we're in charge of keeping that up to date, right? Yep. I think that's maybe what you're getting at.
Yeah, exactly.
Yeah, and because we can build anywhere, boy, we did a good job kind of like coming up with a game design that's like not super trivial.
not for multiplayer, that's for sure.
I guess that's RTS though, right? If you want to be able to build shit, you need to be able to Pathfinder, and you can't whine about it.
Yep.
Okay.
Yeah, it's true. It's true. It's interesting. I wonder once we get to sort of the builder ability of things, if we'll have a better sense of like sort of the throughput of changes that can happen to the map. Like each player can only put a new wall down like once per second just by the amount of builder they have to work with.
Yeah.
And maybe we make walls harder to destroy to also like reduce the churn on that side, because like they shouldn't pop off in one bullet like they do right now. So I wonder if we'll be able to sort of tune it to a expected amount of destruction.
Right. The other thing I was thinking about is like, is there a way that we can make the pre-processing like incremental? Like, is there an algorithm that we could come up with where if you add something, it can make local updates to the pre-processed data structure rather than having to recalculate from the ground up?
That's a great question.
I really have no idea. It seems unlikely, but maybe. All right, that brings us to 9 p.m. We're done.
All algorithms all night long, baby.
Yeah, didn't write any code at all. Sorry about that.
I mean, is that a victory? I think so.
Yes, code is bad.
Yeah.
Code is bad.
Have we reduced the lines of code? No, we added comments. That's too bad.
We did have comments. It's true.
Can you
I am actually curious about.
Yeah.
Do you want me to delete some stuff?
Delete some code in deference to the comments we've added.
Okay. Where do we turn debug draw on? Is it client main?
Oh, do you want it on by default again? I just turned it off because it was faster.
Yeah, where is it on by default? Is it the client sim? The client? Oh, it's this. It's got to be this.
It's like actually a flag, right? Yeah.
Debug draw.
Find the player input system where you turn it on and off. What's the toggle toggling? Do we toggle it
Well,
here?
it's probably just the input system is going to like do a not on its current state. I think debug draw is enabled. It's not enabled. It's not enabled. True, right? That's probably what it is. All right, so that's not what this is. That was my hypothesis.
Oh, right. I forgot about this. Right, the thing to fix. What is that error? It's so...
It's basically saying the render count or prim count is 0. So does that mean anytime we have a draw call?
Render count is like... Is this for our instance rendering? Do we have
Like
a
for our
particle?
particles?
Do we have a particle emitter that's like spitting out nully particles?
The particle system is...
Oh, it's actually one instance draw call that does every
It's just
particle.
one thing, yeah. It's pretty dope.
I was gonna say we really wrote some smooth OpenGL for that one.
Okay,
That doesn't
draw
help.
arrays, right? Num points.
Is there still Webgl Debug in here? Do you want to turn that on?
I think I commented it out.
Oh yeah, it's commented out, but I hope it's... I think we made it to be commentable on too.
I think it was also part of render tool too, right?
Oh, I thought it was in main, but you might be right. Dash debug?
WebGL debug utils.
Yeah.
Where were we using
So
this?
I think we import WebGL debug.
We just import it, just straight up.
Yeah, maybe. Whoops. Damn, you could look at the commit that added this file in there. I'm sure that has the actual usage.
This is in particle toy, but it doesn't matter, right? You were saying that we can just somehow.
You can wrap this around anything, yeah.
And do we need to call something?
You basically replace the renderer. Check out the... Is there a doc in the top comment? This thing is great because it just starts logging everything that looks weird.
Yeah. Let's see. Just copyright stuff.
So useless. I mean, you found the repo. It's right there.
It'll get tree shaken if we don't do anything with this, right? It feels like we need to call some function on it.
Oh yeah, it like will go into the renderer. Check out the GitHub that you got up there. It's like replacing our canvas 3D or our canvas context. Debug context. So
Does this ring any bells?
yeah. So it's wrapping the GL. It's replacing the GL variable, which I believe is our 3D context.
Is that getting created in the client?
Canvas 3D, and then where do we call get context on that?
This one here.
So I think you replaced CTX 3D if we have one.
This
Oh,
one here.
GL. There you go. Take the GL variable, paste exactly that line there, and I think you're good. Yeah. this .gl equals that. Yeah. Mm-hmm.
And then import WebGL.
So
it's going to be like //
Yeah, it's into the particle toy, and I guess is it a JS file?
/tools/ Oh, it's got to be a require, right? I think we could do this. Tools.
I think you could do that. Yeah.
Particle toy.
Mm-hmm. Yeah, that should be it. I think just type it out. TypeScript probably just can't find it. Yep.
Could not find. So I just need to. This needs to be a require, right?
Yeah, totally.
Let's make it an any equals require. And this is then therefore going to have to be relative, right?
I thought we could require absolute paths. Maybe not.
But the tilde does not make it an absolute. Tilde is the TS config thing, right?
There. Yep. Cool. Wait,
Client. Is that the same level as tools?
thought so.
It is. Maybe some more hierarchy would be good. Okay. Is that having a hard time? Not part of import statement. Oh, you know what?
Yeah, just break it. Yeah, cool. Let's just. I think this was going to run before and will run now. We need to copy that throw on GL error function. Oh goodness.
Can I do multiple?
Yeah, you can do multiple. I thought you could. Let's just see if it runs. We're not going to keep this in there anyway.
Well, it's not even going to compile if it's complaining about this. Actually, the no explicit ending should be fine, right? Both of these should be fine.
I think it's going to compile. Yeah,
it compiles.
It'll throw an error on GitHub, but I think we're good. Yeah, I mean, I'm so trained. These are not real TypeScript
Throw on
errors.
GL.
Yeah. So there's a function that's you can copy paste out of the GitHub, but they gave us like a very simple one. Yeah. Just that sucker. Probably not a named function. Wait, you pasted that in a strange place.
I pasted what in a strange place?
Did you paste it in a strange place? Oh, I guess that works. Okay, I'm sorry.
I mean, this require could go anywhere, right? Go.
Yeah.
Let me just console log this.
Cool. I noticed that I think your error is type web debug, Webgl Debug utils 2, and you imported it without that, with a different name. The const does not have a 2 on the end.
Oh.
I think
that's got to be it.
Wait,
where's the 2 again?
The 2 is in your console error.
Interesting. So what the hell is this?
I'm not sure where that one's coming from. Well, we don't have to debug the debugger.
Oh, you know what? This is weirdly a. It's like we just need to go down one level.
Oh, .webgl.
Oh, is this a constructor?
I thought so.
So I need to call this function first.
I mean, I thought the way you're using it was correct.
But it doesn't have. I don't know if you can see this, but it does not have a make debug on it.
Yeah, that's.
But it has a prototype, which I can't.
That's really interesting.
Object.
Huh.
This has a prototype, which I'm not gonna.
Yeah, as I say, this ain't going well. Oh well. Well,
was this that hard to deal with before?
It wasn't. No, it just worked.
Huh.
I don't understand. Are we using WebGL 1 on the particle emitter for some reason? That would be very strange. Yeah, I don't think so.
What if I did this really quick?
Sure.
It's kind of a last ditch sort of thing.
I'm into it.
All right, that works. Come on.
Damn it.
So now that I've done this, what does it do?
I mean, it's supposed to start giving you more useful errors. It gives you like the line number that it's throwing on.
I mean, it is super slow right now.
It's so helpful.
So it's supposed to actually be spitting stuff out? Is that?
It helped me find the actual line number that my calls were fucking up on before. But
am I filtering out something?
I don't think so. I didn't give verbose, but no. This just doesn't seem to be doing a useful thing.
It just doesn't work.
I guess not. I mean, it slows it down.
Is this not working correctly? Throw. Oh, this is just an error thing. Well, shit.
Yeah. Oh well.
That's a bummer.
Yeah. Too bad. I like that the other error has just gone away. By the way.
Oh, you serious?
It didn't show up that last time.
Why is this not?
Shift reload?
Oh, there we go. That was
Yeah,
weird.
there. Now it's back. Okay.
Now it's back. Wow. So
Well,
after all that, this just doesn't work.
yep.
That's kind of
That's annoying. Oh well.
because
Sorry.
normally this was just supposed to print out every single call, right? All right.
So.
We can probably hop off stream, but I'm definitely gonna because I can just like look for which sending a 0 value here, and we'll have to just do this old-fashioned way.
Fair enough.
But yeah, I think for next time, who knows what we're gonna do. Maybe if we can get some headway on the algorithm the next couple of days,
that'd be pretty nice. Yeah, it'd be cool to dive into that.
Yeah.
Sweet. All right. Well, happy Monday. Happy Monday.
Yes.
Thanks for streaming. See you at Twitch.